Hi, my name is Jongpyo Lee, and the work is titled to Metro Learning versus Classification for Disentangled Music Representation Learning. This work was conducted in collaboration with Nicholas Bryan, Justin Salomon, Jae Jin from Adobe Research, and my advisor Joanna. The application we are targeting is audio content-based music retrieval. In general, there are two types of content-based music retrieval, which are tag-based retrieval and example-based retrieval. Tag-based retrieval is to search for songs in the same semantic category. Example-based retrieval is to use a query song to search for songs similar to that one. And there exists an emerging concept of multidimensional retrieval, which finds a similar song to the query song in a certain category. These applications are achieved through representation learning. Representation learning can be summarized in two steps. First, audio and tag are embedded into a representation space. Second, retrieve songs using the similarity between them. This is an illustration of how the tag-based retrieval is conducted in the representation space. It is done by finding songs close to the tag centered in the representation space. The related area of MIR is music auto-tagging. For the example-based retrieval, it is done by finding similar songs close to the query embedding feature. Here, the related area can be music similarity. The multidimensional retrieval can be done by explicitly dividing the embedding space into several musical axes. Once the embedding space is well separated, we can search for music along these musical dimensions. The strategy for representation learning are as follows. Tag-based retrieval is basically related to classification. Example-based retrieval is related to metro learning, and multidimensional retrieval is related to disentanglement. Therefore, to compare the pros and cons of the combination of the representation learning strategies, we first connect the relationship between classification and metro learning using purpose-based metro learning. Then we develop their disentangled version of the models to perform all the three retrieval cases, and then we compare the models. These are the illustration of how the disentangled versions of the models look like. To measure the retrieval performance for all the models in a holistic manner, we evaluated the models on the following three tasks. This is the first work that measures the performance on all the three retrieval cases, because music auto-tagging and music similarity were traditionally treated separately. At last, we also developed a user-annotated music similarity triplet dataset that are linked to the million song dataset from our previous work. Please take a look at the dataset as well. Finally, the contribution of the work can be summarized into these three. First, we outline the relationship between metro learning and classification. Second, we developed their disentangled versions based on our previous work. At last, we show that our proposed approach yields state-of-the-art result on music auto-tagging and similarity-based retrieval tasks. If you'd like to know which model works the best, please take a look at the paper. Thank you.